a webinar about the EGEC Market Report 2023. So it will be a 40-minute webinar. It will be recorded, so it will be available after on our website, and the slide deck will also be available. So what will we present today? All the chapters of our market report. So in this market report, you will find data about geothermal electricity, geothermal district heating and cooling, geothermal heat pumps. For the first time, a chapter about geothermal underground thermal energy storage. You will see we try to collect data and report them, but it's just the first edition, so be sure next year it will be improved. Also, a specific technology chapter this year about the supply chain in Europe, and as usual, an overview of the global market. So I will share also with my colleagues this presentation. What is the first conclusion of the market report and the market development in 2023? 2023 is a year of contrast. You could see for electricity, for district heating, we would have expected more development, more plants in operation. Why? You will see in the market report the reason why these projects were not always been able to be in operation last year. Contrast year for geothermal heat pumps. Why? It's a record year. We have reached nearly 155,000 units sales in 2023. It's a record year. But while you have contrast, we could have expected a faster exponential growth all over Europe. Why? You will see so the reason why. For geothermal storage, we cannot say it's a contrast, it's a developing technology, but you will see from the first data how it looks like. With this short introduction, it's my pleasure now to give the floor to my colleague Emile Martini for the first chapter on electricity. Emile, the floor is yours.
Thank you, Philippe. So I will give you some numbers as regards geothermal electricity. Next slide, please. So in terms of capacity, we reached 3.5 gigawatts electric in geothermal electricity, which correspond to 143 operational plants and generating 20 terawatt hours per year, which is about 7 terawatt hours per year if we consider the EU. If you take a look at the map, you can see a bit the concentration as regard geothermal power in the different countries in Europe. What immediately pops up is that there are 3 big countries in terms of electricity production, which are Iceland, Italy, and Turkey, as the white bubble indicates the existing plants. But as regard the plants and in development of projects, the orange bubbles, you can see that a lot of other countries have planned or in development projects. So we can say that the bigger market, apart from Italy, Iceland, and Italy, can also be considered Germany, France, and recently also Croatia, so a big development of projects. It's important to underline that some countries that are not yet producing geothermal electricity have several projects that are already under development. We're talking specifically about Slovakia, Switzerland, and the UK. And there will be soon new markets that will see that saw the first geothermal power production, which will be expected in the next few years, in particular Spain and Greece. Next slide, please. So here you can see a bit the numbers in details as regard the big markets on the top table and the emerging markets in the second table. So even though there's no new plans in 2023, there are approximately 50 geothermal power plants which are planned, and 8 new projects have started development in 2023. In particular, they refer to 3 projects in Turkey, 1 in Italy, 1 in Slovakia, 2 in Austria, and 1 in Slovenia, which is particularly interesting because it's linked to a pilot project which is going to utilize existing non-productive gas wells. And as regards project under investigation, the numbers are quite high. 185 geothermal power plants are being investigated. And again, it's the big markets that are driving this list, mainly Croatia, France, Germany, Italy, and Turkey. But as I was saying, we expect in the next few years to see also other countries such as Greece and Spain to produce electricity. Considering a bit the market situation, as Philip was saying, 2023 has been a year of contrasts, especially because as regards the geothermal sector, there's been a lack or uncertainty of regulatory support, especially in the big markets I mentioned. Turkey, for example, had a new feed-in tariff that has changed the core fundamentals of the market and is translated in some uncertainty for project developers. Also, France and Germany had a stop-and-go approach, and also Italy was waiting for a new legislation that has finally been approved this year by the Commission to have a further push on electricity. Then, of course, some other macro aspect, like the effect of the COVID-19 pandemic, which slowed down a lot of projects, especially since 2020. The war on Ukraine that added equipment-related challenges, especially to some components and raw materials. And also the higher interest rates, which have caused an increase in supply costs and financing of geothermal projects. And last but not least, we should also consider that the electricity market is not growing in the last few years. For example, the electricity demand fell by 6.4% from 2021 to 2023. So this is not helping much the industry. Next slide, please. But there are also good news for the next few years, because, for example, at European level, the Commission tried to tackle all this problematic and approve. It has been approved at EU level the new electricity market design regulation, which aim to lessen exposure to energy price shocks from volatile fossil fuel utilization and ensure affordable electricity for consumer and industry. And this is good news for the geothermal sector for several reasons. First of all, because this will create a framework for power and heat purchase agreements, which will ensure stable prices. And also because public investment will soon take the form of contracts for difference. And it's important to underline that geothermal was recognized as one of the 5 technologies to benefit from these contracts. As you can see, these contracts mean that the generator is going to receive an income when the price of electricity collapses, but then consumer will receive to some extent, it's when prices go above the agreed ceiling. So the idea is to maintain sort of a market price as regard the price of electricity. Then other good news are linked to this framework, which will enable more flexibility and also some the baseload aspects that will be given by geothermal energy. On the white side, also providing storage, so underground thermal storage, but also the good capacity factor that makes our technology competitive also toward other renewables. Next slide, please. So what we try to do also in this market report is to underline that power plants, geothermal power plants, are the one with the highest capacity factor in Europe, and this since the utilization of geothermal. Usually the capacity factor of these plants is higher on average than 90%, and some operating plants are also close to 100% of the hours within a year. Here in this table, we put the first 12 plants in terms of capacity factor. And this table shows us some different aspects. First of all, the diversity in terms of geography, because, for example, here, Italy, Turkey, Iceland, but also France and Romania are represented. Then there is also some difference in terms of capacity from 0.05 megawatt electric to 120 megawatt electric. Last but not least, also difference in terms of age of these plants, because there are some new plants, relatively new plants, but also some quite old plants since the early 90s. So another aspect to underline is the longevity of electricity plants, electricity geothermal plants, which make our sector very competitive towards other renewables also. Thank you.
Thank you, Emile, for your presentation of the Geothermal Market Report. Before giving the floor to Sanjeev for the Geothermal District Heating and Cooling chapter, I'll just answering two things that were said online. So we try to do this webinar in 40 minutes, so we will not allow presentations to be questioned. You can use the chat. We'll try to use the chat also to answer your questions, because indeed we want to have it recorded and to allow a smooth lecture of this webinar at the second stage. So, of course, presentation will be available. With that, Sanjeev, I give you the floor to present the chapter on district heating.
Thank you very much, Philippe, and good afternoon, ladies and gentlemen. I hope you can hear me clearly. If I go to the next slide, please. So in terms of geothermal district heating, there are 401 systems in operation, of which nearly half are located within the European Union. In terms of last year, there were 8 new systems were installed or commissioned, 3 in Finland, 2 in Romania, and 1 each in Germany, Netherlands, and Slovakia. And what they demonstrate is a real variety in terms of the type of projects that were installed, the lead-in times, and also their size. And let me give you a few examples. So in Finland, you had much deeper closed loop systems. Helsinki Russo is a good example, as well as Eposo in Nitikumpo. Apologies if I mispronounced the regions. The one operation that we had in Slovakia, the Kesmos plant, was a 3.5 megawatt plant, which has replaced 1,500 households who were consuming gas. So again, it's part of the energy transition and the ability to deliver transition at scale. 2 interesting projects coming up. One of them within Romania was a 7.2 megawatt heating network, which was supplying a local sports centre. The interesting thing about this, and it's important lesson when it comes to the need for a European geothermal strategy, is that the initial tender was sent out in 2021, and within 2 years, the actual project was commissioned. So this is the kind of lessons that we want to have learned and replicated across other countries. The project in the Netherlands, again, is another fascinating one. This one took 9 years to develop. This is the Duurzame Vol project in the Tinne municipality. It's a horticulture complex, over 70 hectares worth of greenhouses were connected to a geothermal district heating system at a cost of 20 million euros. So again, it shows that geothermal is not just, and when we think of district heating, we need to go beyond the kind of conventional understanding that we have in residential applications and look at agriculture and also industrial applications. So it's important that we as a community are talking about a much broader spectrum. If I could have the next slide, please. This here is an indication of different temperature ranges that we have within the networks over the last couple of years. And I think what's most striking from this is some of the key kind of trends and developments that we're seeing within the market. And the first and most important one is a trend towards much lower temperatures for the provision of heating. In some cases, lower temperatures with a larger heat pump system, as well as the discovery of new sites for district heating applications. Next slide, please. In terms of the pipeline, one of the key things that we see a lot of development happening in is in this fifth generation of district heating systems. Sometimes it's called network geothermal. But the crucial thing is that of the pipeline of new district heating networks, the vast majority of them are non-fossil. Geothermal is the largest resource with 39% of the market share in 2022. And sometimes what you find is geothermal provides the base load heating and cooling needs, and then it's topped up with a combination of other sources for peak heating demand. But certainly we expect to see this trend to be much more intensified if we're going to deliver on the EU's Repower Europe objectives, as well as the broader climate target that we have to achieve before 2050. Next slide, please. Here we see an example of the conventional district heating systems with geothermal, much more higher temperature systems. Many of them have been in operation for decades. And what we found is that often they were associated with large combined heat and power applications, but by and large, these are big systems for big cities. So naturally, Iceland, Turkey, but also countries such as Poland are the dominant players in that field. Next slide. What we see here is the trend towards much larger systems. So again, just to recap, we're seeing two trend lines, one for larger, complex, and new district heating systems, and then the much smaller, but much more rapidly built network geothermal systems. Now, of the larger systems, the need to kind of drill multiple wells rather than one or two is a key feature we're seeing. Again, the need to have some form of a risk insurance to de-risk the newer projects is absolutely vital, and one of the key things that's needed from the European geothermal strategy. Hopefully something that we can agree over the next couple of years so that we can really boost the number of investments going into the ground. We see newer, much more diverse portfolios of business models where you're combining different operations into a single network, which again is a form of de-risking the financial operations. The focus on closed loop and deeper geothermal projects, again, is another trend line, and one that we've seen in market reports from the last couple of years is, for example, as boreholes are drilled at a much deeper level and heat networks are built out on the back of this. And again, the need for much more aggregated and combined a combination of diverse heating sources or cooling sources. Again, going back to the greenhouses that we mentioned in the slide earlier for horticulture, but we would expect to see a lot more combinations with industrial and manufacturing industries requirements as well. So a very strong trend line is emerging now. Next slide, please. And in terms of the outlook to 2030, you can see a very healthy response rate over the last year in terms of new projects that have been initiated or are in the process. Germany, by far, is one of the leading players with 102 in the pipeline, but there are many notable countries that are worth looking at. Romania being another example, there are 6 in the pipeline there. France, one of the largest district heating countries at the moment, has 24 projects in the pipeline. The Netherlands is increasingly intensifying its activity in the space. 22 projects are in the pipeline there. But we're also starting to see countries such as Serbia, such as Spain, Slovakia, and of course the UK are starting to ramp up when it comes to their heating and cooling decarbonisation. So these are very, very encouraging signs, and certainly one of the reasons why it's essential to get a collective, coordinated approach to geothermal across countries, so that we can share a lot of the learning experiences and realise this in the next couple of years. Next slide, please. Thank you. Here we have the kind of some of the numbers behind the pipeline, the operational, but also the pipeline. So again, some of the standout numbers from this is countries such as Germany, where you have a big pipeline of projects which are in development. You have countries such as Iceland, which are waiting to develop more and more projects, but countries such as Italy, Poland with 21 projects are starting to ramp up their intensity. So again, this reinforces the point that was made before. There is a significant demand for geothermal district heating and cooling systems to be built. It's vital for us to get the market mechanisms in place. If there's any manufacturing capacity that's required, it needs to be in place very, very quickly. But at the same time, we need to give as much support as we possibly can in terms of developing business models and supporting the actual construction and project development across the countries. You can see from the last column, the other projects, there's 91 projects in various stages of development, and we're going to go through those onto the next slide. Please. Thank you. So from this, there are a couple of very fascinating examples. As my colleague Emil mentioned earlier on, Croatia is one of those countries where many people within the industry are having a keen eye. Here you can see 20 projects for district heating and cooling are in the pipeline. And what's significant about this is that will be a significant chunk of the national demand for the country. So really, if we can help a country like Croatia with its own national strategy, its own better implementation of existing laws, but also giving it access to the pool of expertise in neighbouring countries across the EU, but also internationally, then this is an example where geothermal would have a major, major impact in the EU's energy transition. Other countries within this, again, the UK, a newcomer to this field, is one that's been closely looked at. There are a few examples with social housing in the UK, which are very, very notable. So the big, large tower blocks, in the past, it's been very difficult to renovate them, but geothermal has shown that you can renovate them en masse and reduce costs and provide a social benefit as well as the environmental and energy impact. A few other countries which are worth looking at here as well, or highlighting here, Portugal and Lithuania. These are, and again, newer players to the geothermal district heating space. But again, geothermal is going to be a key part of their energy transition. So again, as much support and coordination as we can give to them, we should see these countries start to rapidly increase their investment space. Greece, I just want to highlight it, as well as Belgium. These are countries where geothermal is starting to move much more further up the scale. The difference between the two, in Greece, there's also a tendency to focus a lot more on cooling. The Limassol complex, one of the iconic projects in all of Europe, is principally a cooling project. Whereas in Belgium, you're seeing a lot more heating demand where regions, particularly southern Belgium, the region of Wallonia, is rapidly replacing its gas systems with geothermal heating and cooling systems. And importantly, they're also combining the demand wherever possible with residential buildings and commercial or industrial applications. So a lot of exciting things are happening on the ground. Next slide, please. Oh, thank you very much.
Thank you, Sanjeev. And now it's my pleasure to present you the chapter on geothermal heat pumps. So what is the situation? I mentioned that in my introduction. 2023 was the best year in terms of sales. For the second consecutive years, we have a record-breaking. Last year, 300 units were sold in the EU. It was a nearly 12% increase comparing to 2022 sales. You can see the 5 leading countries: Sweden at 26%, Germany at -1%, Netherlands +11%, Finland -0.4%. You remember my introduction? Indeed, 2023 is a year of contrast. What is always for us surprising is that 4 markets in Europe represent more than half of the total number of geothermal heat pump sales in a year. You can see Sweden, Germany, Netherlands, and Finland are representing more than 55%. It means that the potential to develop geothermal heat pumps all over Europe is really huge. How we are in terms of stock. So I mentioned 154,000 new units in a year. It brings us to a total stock today of 2.32 million of geothermal heat pumps in operation. to go to some granularity in this capacity, the large majority, nearly more than 2.3 million, are small-scale units. We said 10 to 15 kilowatt units, typically for individual buildings. Indeed, it represents a capacity of 33 gigawatt thermal. Sanjeev was presenting fifth generation of geothermal heating. We are mentioning larger systems with geothermal heat pumps. Where we are in these large systems, what we'd say larger than 50 kilowatt thermal. This can be discussed, of course, this threshold. But today, we have 2.6 gigawatt thermal of these large units. Always important to report not only units, not only capacity, but production, because geothermal heat pumps are highly efficient with a coefficient typically higher, of performance typically higher than 4. So in 2023, we consider that we have produced 83 terawatt hour. So we supply heat and cold to more than 10 million inhabitants in Europe. To answer the question I raised in the introduction about the year of contrast, what is influencing this heat pump's timid growth? It's a growth, but it's not really a growth all over Europe and not at the same growth rate. And if in 2022, one reason was a micro internal, we could say, factor, it was due in some countries to lack of drilling capacity, 8 to 10 months delay in drilling for geothermal heat pumps. In 2023, the main factors which make the growth slower than expected are macro level factors. My colleagues already mentioned the inflation, but on top of inflation, we have seen current increase of interest rate. The interest rate had a direct impact on the construction sector. So what is clear is that in 2023, a decrease in the construction of new buildings and a decrease in the renovation rate of buildings. Two factors which are, of course, impacting the development of geothermal heat pumps for refurbished building or for new construction. A second macroeconomic factor, really important last year, was, of course, inflation was also due to high electricity prices. And the high electricity prices, all for geothermal heat pumps are highly efficient, have also an impact on the performance and on the cost of geothermal heat pumps. On top of that, it was not only high electricity prices, but it was also high taxed electricity prices in comparison to low taxed gas prices. So the comparison between the taxation of electricity and gas makes all systems operating with electricity less competitive in comparison with gas, because gas taxation was lower than electricity taxation. It's a topic as EGEC we try to work on the policy side, but it has a direct impact on the market. And you could see on the graph to illustrate that indeed the number of geothermal heat pump systems per 1,000 households is an indicator we like to show, because in some countries you have really a high penetration of geothermal heat pumps like Sweden, Finland. There's no reason to not have this high penetration in the rest of Europe. And if we speak about the same level of penetration in the rest of Europe, we'll speak here about a mass market with exponential growth. To conclude the chapter, we also do some forecasts. And to look at the forecast, we also look at the full picture of the heating and cooling sector. And you can see, maybe let's start with the graph on the left at the bottom, is that in Europe, we have a bit more than 110 million buildings. We are used to say that 70 to 80% of buildings have inefficient fossil fuel boilers. So we speak about a market to more than 80 million heat appliances to install in the next decade. To answer this challenge, the European Union established a plan called the REPowerEU plan, with a first target to add 10 million hydronic heat pumps in the next 5 years. It was published in 2022, So 2023 was the first year for implementation, and the first target is 2027. And thus, we look at what are the current market trends and what are these objectives. On the 10 million who have been using, it can be questionable, but let's say a 40% share for geothermal heat pump and 60% share for air source heat pump. So it will mean that to go, not 2 million heat pumps, 20% market share, my mistake, sorry, 20% market share, so additional 2 million heat pumps in 5 years. So doubling our capacity in 5 years. Today, we are not doubling the capacity because doubling the capacity would mean to have more than 250,000 per year, and we are only at 150,000 per year. So in the next 5 years, if we continue this growth rate, we will not be able to answer the challenge. But I told you, 5 markets are representing 55% of the market. So let's develop geothermal heat pumps everywhere as it develops in Sweden, and targets will be reached. In 2030, it's a bit longer term objective. The objective is to have 30 million additional heat pumps. 30 million is more or less 1/3 of the inefficient fossil fuel boilers to replace in Europe. The challenge is huge. The technology exists, is affordable, is competitive. So let's work together to see in 2024 a better market picture. And with that conclusion on the geothermal heat pump market, I give the floor to my colleague Julia for the global picture. Julia, floor is yours.
Yes, thank you. Hello, everyone. I'm Giulia Cittadini, Policy Advisor here at EGEC. And next slide, please. So in my presentation, I'm going to provide you a brief overview of what's the current situation of geothermal across the world in 2023. And particularly, I'm going to focus on this figure, which is quite representative of the situation during last year. So what we know, this is a graph providing us information on the top 10 geothermal countries in 2023 in terms of installed geothermal power capacity. And we see that in 2023, we reached more than 16 gigawatts of installed capacity, which is good news. And this represents also a growth in respect of 2022 of more than 281 megawatts. So this is good because this means that this sector is growing globally. If we also look at the countries represented, we see on top we have the US and closing the list we have Japan. But if we see at this country, so we have US, Indonesia, Philippines, Turkey, New Zealand, Kenya, Mexico, Italy, Iceland, and Japan, as I said, we see that these countries comes from different areas of worldwide. So this gives us the idea that this geothermal power capacity is not concentrated in a single area or single continent, but we have representation all over the world. Also, these countries altogether, they represent more than 93% of installed geothermal power capacity, and the other 20 countries are there, and they altogether they represent a bit more than 1 gigawatt. So what this means? Basically, there is a lot of untapped potential, and there are a lot of also new entrants in this market. And so this was just to give you an idea of some of the key findings in terms of geothermal across the world. But these chapters deep dives also in, of course, in electricity capacity, but also in geothermal heating and cooling development. And a subparagraph is dedicated also to geothermal minerals, in particular looking at the potential of lithium. So I really hope you will enjoy this reading, and thank you for the attention. That's all from my side.
Thank you, Julia, for this short presentation. Indeed, the overview on the global market is presented in the full version of the market report. For electricity, we have clear data. For heating and cooling and minerals, we just present some first information, but hope in the future we'll have better data. To conclude this webinar, I just present you shortly the technical chapter, which is about the supply chain. It's a long reporting to do. The market report will just present you an extract of a study we will publish, probably release in September. It will be a 50-page study on the supply chain. The market report is just extracting the key information in 4 pages. Why we started to work on this chapter is because first, the COVID-19 pandemic, and secondly, the war in Ukraine demonstrated a dependency of Europe, but also the general sector on third country and raw material, components, and equipment in terms of security of energy supply. Geothermal technologies, especially heat pumps and district heating, experience delays due to the equipment shortage, impacting also project timelines and development in 2021, especially, a bit in 2022, less in 2023. As you all know, the development of the geothermal project involves several stages, from site investigation, resource assessment, drilling, resource utilization, operation, and now more and more decommissioning. Each stage requires specialized expertise and equipment. When we speak equipment, we speak mainly about assembling different components. As I mentioned, in terms of equipment, we have to look at also the manufacturing of components and the supply of raw materials. Short conclusion in this presentation is that geothermal equipment and component manufacturing is largely made in Europe. It will surprise us, it will probably surprise you also in the report, full report we publish, how the companies operating also in oil and gas are providing service equipment already to the main markets in Europe, assuring a made in Europe capacity. However, the supply chain remain, especially for some raw material. Important to highlight, these are not critical raw material, but anyway, these are raw material which are not supply made in Europe and can concern shortage of equipment and components, is about concrete, steel, and aluminum. Also for electronics, especially in heat pumps, but also in other equipment, and certain metals imported essentially from Asia. If you look at all the technologies we have in Europe, geothermal electricity, being high temperature, low temperature, binary or flash steam, geothermal heat pumps, geothermal district heating, geothermal underground storage, and extraction of minerals, we speak about a lot of equipment, a lot of components. We cannot sum up that in 4 pages. It's why we are drafting a full report on this topic to be released in September. It's time now to conclude this webinar, and just to tell you, we want a big thank you to the 3 sponsors of this 2023 edition. Indeed, thanks to them, we can better promote, better also do this market data, market treatment. So a big thank you to EGEC, to HNP, and to Hunting for supporting this 2023 edition. I hope you will all enjoy the lecture, the reading of this market report, which is about to be released. I thank you all for your attention and hope to see you soon. Have a good afternoon. Bye-bye.